afternoon, everybody. Today we are going to take our data, our lovingly crafted and cleaned data, and we are going to make some visualizations with it. So we're moving out of the realm of the pure text and out of the realm of the pure data and doing some of those fancy things that we always really like to see in our presentations. What I'm going to be doing today is really important to understand is just sort of the tip of the iceberg. I'm going to give you the tools to make a very simple visualization, but it is essentially a drawing program. So once you understand the components of your image, you'll be able to devise any sort of image that you really want to represent your data. So we'll do some experimentation this week, and next week we'll start to build things together to sort of answer specific research questions and specific research problems that you have, and move into that next phase of the project. So let us begin with turning up the heat map. So the first thing we want to do is to understand what we are going to be using. And the tool we're going to be using is something called Plt, which is a library, another library for our collection, and it's an extremely powerful one. It's one that lets you, at the most basic level, create graphs. So the kind of graphs that you would see in Excel or a different spreadsheet program, bars, scatter, things like that. But really what it is a renderer. So if you can imagine it, you can probably make it with Plt. The other thing that's really useful about it is that everybody else uses the same library. So there are not only huge amounts of documentation, so you can just look up, how do I do this with Plt? There will be examples all over the internet, people asking the same question and showing examples. So it's a really good community building kind of library. If you can imagine it, somebody else has probably given an example of it somewhere. Now, in order to do something with this, I've decided that we're going to make a heat map. Now, there's lots of different ways to visualize a heat map, but we're actually going to make a one-dimensional heat map, which is, for all intents and purposes, looks like a barcode. And what it will be is a single bar that represents our text, our novel, with a vertical line every time a certain word appears. So you'll get the DNA, or the barcode of that word within that text. It's very basic, but it gives you the stepping stones to do something more interesting later on. So in order to make an effective visualization, we're going to need our data in a particular format. And the way we want to do that is this here. Now, what that means is we want to create a dictionary. Now, we did dictionaries last week, and we're going to do those in a bit more detail this week. But the idea would be that you would have a single word, such as the, or cat, or in, and afterwards, you would have a list. So, when you make any kind of dictionary, you have a key, and you have a value. And that value can be anything. It can be an integer, it can be a string, or it can be a list. It could actually be a dictionary as well. You could have nested dictionaries, but that's getting a little bit meta. So in this particular one, we want to have a list for each of these words, and in there, we want to have some kind of representation of where those words appear in our text. And the easiest way I could think of doing that is literally which number word they are. It's the first word, the 7th word, the 12th word, the 16th word. So it'll look something like this. Going down for every single word in the dictionary. Things like the are going to have lots of entries because the appears quite frequently in English text. Things like cat, maybe fewer. And once we have this dictionary, that basically means we can say, look up a particular word and use that list to create the barcode. Does that make sense to everybody? Yes, okay. So how do we get our novel into this format? Well, the first thing we're going to want to do is we're going to want to get a dictionary in this format. And to get a dictionary in that format, we're going to need a list of words to begin with. So let's think about that further back. How do we get the list of words? Well, we need to regularize a text, which means getting rid of all the punctuation, making it lowercase. And even before that, we need the text itself. So I suggest considering the season, we use this Gutenberg text for today. And there's also one more thing we're going to need to do. Since we're going to be looking for word frequency, we're probably going to want to know the most frequent words. We're going to want to know the words that come up most often, as opposed to just having one little line in our whole barcode. Which means the most common words are going to be the, of, Now, for some kinds of research, articles and prepositions can be really interesting. They can be really critical. Not for today. Today we want the more meaty words, the adjectives, the nouns, the verbs. So we need to get rid of these types of words. And we do that by using a stop word list. Now, there are so many stop word lists on the internet. Basically, if you type in stop word list into Google, you'll find natural language processing groups who have made stop words for English, stop words for various other languages, and stop word lists for certain disciplines. So words that are commonly used in the sciences or in art that you don't necessarily are not as interested in. So I've already obtained a very basic stop word English list, which I've put later on in this notebook for us to use. But in your own research, you can find those pretty easily. And you just use those as a string, or upload it into a string, the way we do with other files. So, what we're going to do is we're going to create a small amount of code here that does all of those basic things. Now, as you can see, I've actually written something in your box to begin with. And this is called pseudocode. Now, previously, I've been making little bulleted lists for you in the documentation, and you were having to translate that. But that's not normally how you would program things. Normally, you would write out your entire program in pseudocode to begin with, which means an English language, or whatever language you choose, instruction manual for yourself. If you were explaining your program like your program is a child, step by step, what would you tell it to do? And the way that you do this is you leave these in. These are comments. You would not remove them later. But you preface them with this pound or this hash mark. And anything that you put after that number mark is commented out, which means the computer doesn't run it. It just ignores it. So you can read it, I can read it, but the computer ignores it. So you can write little notes to yourself. And it's actually quite fun to read other people's code, because sometimes people talk to themselves in a very narrative fashion, and they'll be like, don't forget to get lunch or something at this point, and they've forgotten to take that comment out. So, we're going to go through all of these different steps and recreate a way to download a text, regularize it, and split it into a word list to work with today. So let's begin. So, we're going to have to import some libraries. Does anyone remember which libraries are relevant to this task? What do we need to know how to do? Regex, yes. So import reg. Anything else? Yes, it was request. With an S. Okay, first part done. Now we need to download our text from Gutenberg. So how do we go about doing that? Get, yes. So, what shall we call this? We will call this downloaded string, because I'm very creative in how I name my variables. And it is requests.get. And then we put in our URL. Now, usually when we've done this in the past, we've made the URL its own variable and then stuck it in there, but you can just do that directly with the speech marks. So I'm going to take this Gutenberg text up here and stick it inside my speech marks. Okay. Now that we've got the text, what do we do with it? How do we format it as plain text? Dot text, yes? So, download string equals download string dot text. Okay, now here comes the fun one. How do we remove the punctuation marks? Which library do we use? Regex, absolutely. So, again, download string. Actually, at this point, I'm going to call it my text. Equals, and we want to substitute one text for another, so it's read.sub. And inside that, remember the format is what you're replacing, comma, what you're replacing it with, comma, and then the name of the variable. So download string. So we're replacing it with nothing, so we can leave this blank, but we do have to tell it what we're replacing it with. Now, does anyone remember the regex string that we used? Or at least the formulation of it. What were we telling it to do? Yes? So anything that's not a word, and anything that's not a space. And then we have a symbol. We put this inside of what? Square brackets. And what square brackets, I don't know if I explained this previously, but what square brackets means is anything that's in here. So it could be a not a word, it could be a not a space. It's anything that's in there. And then we have a symbol afterwards, which is the star, yes, which means 0 or more of those. So there we go. Anything that's not a word, anything that's not a space, as many of them that they have, get rid of them. Now, how do we make it lowercase? Another simple command. Dot lower, yes. So my text equals my text dot lower, and what's lower followed by? Brackets, yes, because it's a function. You're telling it to do something. I'll move that up a little bit so it's a bit easier to see. Okay. Now this is the part that you may or may not remember because I did it for you last time. It's how do we remove the header? So we've got this text that has no punctuation, it's all lowercase, but it's got that annoying Gutenberg copyright statement at the top. So does anyone remember the process of how we get rid of that? What you want to do first is you want to find the start of the header. So the start is my text. So you're looking through my text and you're using the find command. So my text dot find in brackets, and inside the brackets you want to put start of this Project Gutenberg ebook, because that's how all the headers start. And you could probably get away with start of this, but for completeness, start of this Gutenberg project ebook, Project Gutenberg ebook. So what do you think the find the start of the footer is? End equals my text dot find, and in the parentheses, does anyone remember? End of this Project Gutenberg ebook, yes. Okay, and what's the command to trim that header off and that footer off of your big text? Absolutely. So, my text is now going to be my text, but only a portion of it. So what do we put as the starting point? Well, the number is called start. So we've got start plus, and it's 37. And it's the same with end. Because you wanted it to actually start with end, which is the E, you can actually just put end. You really shouldn't put a number after it. That was my mistake previously. So start plus 37, so it starts with the K after the K, and then it stops right before the E, which is where the end marker is. Okay, last bit. How do you split it into words? Very good. My text equals my text dot split. And as always, I'm going to add a little print function just to make sure it worked properly. Oh, sorry, it's not my text, it's my words, because you want to make it a new list. My words equals my text. And I'll print off the first 100 or so. And there we go. So while we're finishing up there, we now have a word list. And what we need to do with that word list is we need to put it into a dictionary. Now, the dictionary we want, as I said before, is similar to this. So we want it to go through every single letter, every single word in our word list. And and we want it to create a new list, which is going to include that number. Now, we know how to make a dictionary, and we know how to put an entry into the dictionary, how to create, a blank entry. But all we did last week was we kept adding +1 to it every time. So we're going to need to find a way to create this kind of format instead. So let's have a think about that beforehand. So what's a possible way that we might create that list? How would we create a list of every single number that that word appears at? So the engram is about creating little 3-word chunks. So sort of ignoring everything we've done previously. We're doing something entirely new this time. How would you do it? How would you explain it to a person? If I were to say, find out which number word the is in this sentence, what would you tell them to do? Count from the start. Very good. That's exactly what we would need a computer to do. And it's something that we don't want to do because there are literally 10,000 words in this text. And that would be very boring. So our computer, which doesn't get bored, can do it for us. So what we're going to want to do is we're going to create a new program. And that program is going to create a dictionary. Pretty straightforward. It's just the curly brackets empty. We're going to want it to create a new list. And we're going to go through this step by step. But we're going to want to create a list, fill that with numbers, and then stick that in our dictionary. And then when we get to that word again, we want to take that list out, add a new number to it, and stick it back into our dictionary. So let's see how we can do this. And this text up here is just for you to review later on. We'll do it through the pseudocode here. So, first step is to create a blank dictionary. What should we call our dictionary? Let's be creative. I'm sorry, Guy. Okay, we're going to call it Guy. Guy Dictionary. Now, how do you create a blank dictionary? What symbols do you use? Curly brackets, yes. So, pretty simple. We have our dictionary with curly brackets. Nothing else we need to do there. Now, if we're going to count the numbers, we're going to need some kind of counting variable, an iterator. But because we're human beings, and we don't believe in word 0 the way that computers do, let's start with I equals 1 this time. So the first word is going to be number 1. So just simply I equals 1. Now things get a little bit more nested. So we need to create a for loop for your word list because we want to go through every word in our word list and add it to our dictionary. So how do we format the word list for loop? For, yes. They're not trick questions, I'm just leading you through it. For what? Well, I is our iterator, so we don't really want to use the I. We want to go through a word list. So what is each thing in our word list called? Yes, for word in my words, I believe I called it. In my words, yes. And put that colon there because that's important. Now, as I said, these comments just get ignored by the computer. So you can actually just go down to the next line underneath this comment. But do remember that because it's part of your for loop, you have to indent. I've indented the comment to sort of remind you, but indented there. So, now that you're inside your word loop, your for loop, you want to create a blank list for those index numbers. So, what should we call our blank list? We're not going to get too creative here, we'll forget. And how do we create a blank list? An empty list. Square brackets, yes. So again, strings are quotation marks, lists are in square brackets, dictionaries are however you make curly brackets with your arms. Okay. Now, you want to assign the existing value for the keyword to an entry variable. So, how do we do that? So, how do we get the existing value for that keyword? How do we get it? The clue is in how I said it. How do we get the keyword? So, our dictionary is called Guy. We want to look up the word that's in our for loop. And we want to get So this little symbol, this guy is the dictionary, get is the function, and word is the parameter. Retrieves the value of that particular keyword. But we don't want to use it in that form. We want to assign it to something. We want to put it in a holder variable. We want to write it down on a piece of scratch paper, basically. So we'll call that entry. This is our temporary entry. So it goes to the list and it finds out its value. Now, it might not have a value. If it's the first word that we've ever done, the first instance of that word, the value is going to be a null value. Now in Python, there's lots of different ways to represent this. The easiest and the way that's going to work the best for us is actually to call it none. So if entry is equal to capital N-O-N-E, and it should turn a color because it's a reserved or a special word, none. So if entry is none, if it doesn't exist, we have to do something. So if there isn't an entry, what do we have to do? We have to create one. Okay, so entry equals a list, and what do we want to put inside that list? We don't want to put in the word, because we already know what the word is. We want to put in the number that that word is. So what variable do we use? Yes, I represents what number we're on. It's the little child we have enslaved to count for us. Okay, so if its entry is equal to none, make the entry a blank list with that one number in it. Perfect. Now let's say it does have a value. And the way that we say, if this, and then the other half of that, so if not this, is called else. So in other instances, if this, else while do this. It sort of makes sense in English. So it's literally just else. If you want to do lots of if statements, you could do if, else if, else if, else if, else. Else is kind of the last result. It's you know, if nothing else works, do this. So else, we need to append the new word number to your entry list. So we need to take the entry, which is already a list, and we need to append a new object into it. So what are we appending into it? Yes. So what this basically does is it takes the entry list and it adds a new item to it at the very end of it, and the order doesn't really matter, and puts that new number onto it. Okay? So now entry is a bigger, stronger, better list. And now we want to assign that entry, that new entry, back into our dictionary. So how do we put that value back into our dictionary? Does anyone remember how to assign a value to a dictionary? So it works the same way that index numbers do. So you have your dictionary named Guy, and you want to look it up. So if you want to look up the first entry in your dictionary, you would put the number 1 or the number 0. But if you know the word that that key is, you can look it up by the word. So remember, word is a placeholder variable that we've been using, so use the same placeholder here. So Guy, word, so that little spot in the dictionary that is defined by word in your dictionary, equals entry. And that's how simple it is. It is going to delete whatever was there and put that whole new one in its place. Now remember, when we were doing this with our other dictionary, we didn't want to do that. We didn't want to keep putting the 0 on there. We wanted to add 1, add 1. This time, we do want to delete it. Get rid of the old definition, it's no good. Put this new entry in its place. Okay, and the last thing that you want to do, and again, make sure that it is in the same indent as the if and the else, because this is still part of your for loop. You want to increase your iterator. You want to tell your slave to add one more number to the count. So what do? I equals I plus 1. Very good. And see that for yourself. And it will think for a moment. And it will create a gigantic, I really shouldn't have printed the whole thing. That's okay. But just so you can see it online, the word masters appears at word 7,568, 40,853, 67,800. So, the next thing we're going to do is we're going to create two helper variables, and that's just going to help us a little bit later on. So when you get down to this one with the stop word list and the word count, change my words to whatever variable you used for your word list, if you used a different one, and then just run this box. And that basically just gives us our stop list and our word count. So you don't really have to change much there. You can just run it. What we're going to do is we're going to explore matplotlib. There's probably actually a way you're supposed to pronounce that, but I don't actually know what it is, so we're going to call it matplotlib. It's probably mathematics plotting library. I'm going to go with that. So, there are lots of different variables. Again, this is going to explain it to you when you're reviewing it, but I'm going to go through the pseudocode now so that you can see it. So, when you use matplotlib, what you're basically doing is you're drawing every part of the figure, every part of the graph, bit by bit. So, what you do first is you want to instantiate that figure. You want to make a figure exist in the Python code. And the way we do that is through, you do have to go up here for a minute and run this bit of code. It may take a minute, so it's good to get that going. From matplotlib import pyplot as Plt. Basically what that's saying is we don't want all of matplotlib because it's gigantic. We just want this little sub-library, which is called pyplot. And because we don't want to keep typing pyplot over and over again, we're abbreviating it to Plt. And that's sort of the standard abbreviation for it. When you see sample code online, everyone abbreviates it to Plt. So once you run that, come down here. So plt.figure creates a chart. Plt figure, and then you can do lots and lots of variables here. If you go to the documentation, there's lots of cool things you can do, but we're only going to do one thing today, and that's tell it how big we want it. And I've made it 10 inches long and 5 inches tall. Now, it'll shrink it down to fit onto your window, but if you try to print it, it'll make it full size. So you're giving it good resolution, basically, is what we're trying to do. So that makes the size of it. These three lines are the dots on your plot. The first list are all the x values, so the horizontal value. The second list are the y values. So remember Cartesian coordinates going up. And so 1, 2 is the first point, 5, 4 is the second point, 6, 1 is the third point. And you put them all together like that if they have the same color, if they're the same type of thing. So in this case, we're labeling it A, and we're coloring it red. Now, if you're used to using hexadecimal colors, sort of like when you were making websites, you can put in those codes as well, or you can just type the word. It works fine. So I've made 3 red dots here. I've made I made 1 blue dot, so that's the X, that's the Y. And I've made 2 black dots, XX, XY, XY. Everyone get that? Those are the coordinates. Yeah? Yes, all Python is in American English because we are cultural imperialists, and we have to export color that way. It's annoying, I know, but it's the way it is. Set access limits. What these two numbers are basically doing is saying how long you want the x-axis to be and how tall you want the y-axis to be. If you don't put those in, it'll just make it as big as it needs to be to hold your data, but sometimes you want to make it a nice square or you want to have specific ones. So in this case, I've made it the same as it is up here, but you can tell it to do things. These two are the tick marks. And what that basically means is what do you want labeled on the x-axis versus what you want labeled on the y-axis. And you can make that anything you want. So I've used whole numbers here, but you can make them words. If you could make them fractions, you can make them whatever you want that fits your data correctly. You have a lot of control here. Again, if you don't put anything in, it'll just try to match your data as best as it can, But if you want control, you can add these lines. The title, nice title at the top of your chart, pretty straightforward. Legend location. This command creates a legend if you don't put anything in this bracket. And in the bracket, you can tell it where to go. And again, you can use English. Upper right, center, upper center, upper left, lower left, however you want to put it. And then this command right here just shows it. It displays it within Python Jupyter Notebook. There's another command here that's called Plt Close. And what that basically does is it removes it from memory so that you're not constantly overwriting it, because if you just keep adding things to it, it'll just keep drawing on top of the image you've already done. So this basically, after it displays it, blinks it from memory so you can start over again. So, all of this should be properly formatted, so if you just run it, you'll be able to see your graph. You've got a nice little, well, a totally meaningless scatter chart. Now there's lots of things you can do. For example, if you go here, instead of scatter, you can also make it a bar or a plot. And plot is a line graph. So if I run that again, you can see, oh, you can't have the bars. The plot is only one dot, so it's not going to do anything. Let's try that again. Plot and bar. So you have, we're going to say modern art at this point. It kind of looks like a person, don't you think? Just kind of on the side. Okay, so that's something you can do. You can also fool around and change where, again, it's in American English for center, where your legend gets put. All of these things let you just kind of play around with these variables so you can get the hang of what it is. Now, if you were going to make a bar chart of all of these things, you can see you've got lots of different colors at different points. You can see that I've got even numbers here and odd numbers there because that's what I told it to do. Could you imagine going through all 50,000 words and typing in the XY coordinates? No, that would be a silly thing to do. Again, the computer doesn't get bored, make the computer do your work for you. So, we're going to go down to this section here, and we're going to format our data, our dictionary, in a way that it works well with this little program to create a graph. Now, the first thing that we're going to have to do, however, is we're going to have to find out what we only want to put the most populated number, the most populated word, the highest word. We don't know what that is at the moment. It's somewhere in our dictionary, but we're not sure. And it doesn't really matter what the name is yet. We just want to find out which one is the longest list. So how do we find out the length of a list? Len, yes. So what we want to do is we want to go through all of our dictionary entries, measure the length of each list, and find out which one is the longest. And the easiest way to do that is to have a placeholder variable. So we start with 1, because we assume something in our list has at least one thing in it. And we say, okay, we're starting with the assumption that the longest list is 1. Go to the first list. How long is your list? 4. Oh, okay. Change 1 to 4. Go to the next item. How long is your list? 27. Oh, okay. Change 4 to 27. How long is your list? 2. And we don't care about 2. We like 27. Stay with 27. And you keep going that way through all of your lists until you figure out what the highest number is. So let's go through this really quickly. So, we want to create a value variable with the value of 1, because again, we thought there's at least one list that has one item in it. Then we want to create a for loop that goes through our dictionary. Now remember, when you're going through a dictionary, the for loop is written slightly differently. Does anyone remember how to do a for loop with a dictionary?
So in order to create our for loop with the dictionary, we need to have 2 placeholder variables, because we need one for the key and one for the value. But because value is something we've already used before, we're going to use the placeholders key to represent the word in our dictionary, and counter to represent the list of all the instances of that word in our document. So for key counter in guy.items, where guy.items is running the items function on the Guy dictionary. Now once we do that, we want to have an if statement. And the reason we have that if statement, of course, is to make sure that the value we're changing it to is greater than the value we already have in our placeholder variable value. So we look to that particular entry in the dictionary, which we represent by Guy with key in square brackets, and that returns a list. Then we use the len function in order to count the number of items in that list. So 4, 5, 15, 107, something like that. Now if that new number is bigger than what we already think is our biggest number, our value, we replace value. So value equals with that new number, len, Guy, key. If it's not, if it's a smaller number, we just go back to the beginning of the loop, move on to the next word. Now once you go through that loop and you've written it out, go ahead and print the value to see what the value is in our particular document. And if we do that, we get 9,857, which means something in that dictionary has 9,857 instances. That's the largest or the most common word in our document.
So look up the counter, which is what this is doing, find the length of it, see if it's greater than value, and if it is, change the value to it. Does that make sense to everybody? And then just to make sure it works, print that final value. And it's 9,857. So something in there has 9,857 appearances in our text. And I almost guarantee you it is the.
So once we have the top word, the word with the most instances, we want to be able to find a number of other words with high numbers of instances. So in this case, we're going to do the top 5 words, the 5 words that have the most instances within our text document. So first of all, we need to create a list to contain those top 5 words. And so we're going to call it, creatively, top 5 equals square brackets, so a blank list. Now what we need to do is to go through all of our words again and find the 5 that have the highest value. But rather than go through every single one the way we did for the top value, we can sort of cheat. So we start with that first value that is the highest number we have, and then we start counting backwards down to 0. So if we start at 9,857, we get that first word, then we go to 9,856, look to see if any words have that many instances, and if not, go down to the next. And we keep doing that until we get 5 words that have the highest number of instances. So let's look at our for loop. So again, we're going through all the items in our dictionary. So for key counter in guy.items in brackets. Now what we're going to do is we're going to look for a couple of different situations to be fulfilled or conditions to be fulfilled. The first is the word we're on have the same value as the number we're on? So does it have the same number of instances as the number we've counted down to? If that's the case, it asks the second question. Are there fewer than 5 words in our top 5 list? Because we only want 5. If we have more than 5, we should just stop. And the third thing we want to ask is that keyword in our stop list? Because we don't want a lot of thes and ofs and us. We want to have just real words, substantive words. So if it's the right value, our list isn't full, and it's not a stop word, then it does the next instruction, which is to append that word to our top 5 list. Top 5 dot append with key in brackets. So now that we've added that word, we want to look for the next most common word. So we go back into the beginning of our for loop within our dictionary. And it goes through the rest of the words to see if anything else has that same value. If it doesn't, if we get to the end of our dictionary, we go down to the next line, which is value equals value minus 1. That's going down 1 on our counter. And we start the whole process again, looking for anything that has that many instances of the word in our text document. Now just to make sure everything is working correctly, at the very end I print the top 5 list. And the top 5 words in this particular list are Will, Fox, Catsby, Viviana, and Replied. Now that we have our list of top 5 words, we want to be able to graph them. We want to create our visualization. So we're going to go through the same steps that we did before about how to create a matplotlib visualization, and we're just going to fill in with a couple of variables that we've created previously, so that this is being made automatically as opposed to us putting in the numbers ourselves. So the first thing we want to do is to create or instantiate the figure. So plt.figure with fig size equals 50, 5 in brackets. Now this is basically just creating a very long, short kind of graph, one that's 50 inches long and 5 high. Now that seems really big, but remember it's going to shrink down to fit into our window. Next, we want to create each individual line in that graph. But again, we don't want to do it manually, we want to use a for loop. So we only want to do the 5 items we have in our top 5. So let's start there. For item in top 5. Then, for each of those, we'll need to go through our dictionary in order to get that list of instances. So for word numbers in guy.items. This is the same thing as for word.counter, I've just used a different variable here. So when we go through the dictionary items, we look, is the word in our dictionary the same as the word in our top 5? And if it is, remember, always use 2 equal signs to ask an equals question, then we plot that particular line. So plot.bar, numbers is that list of different instances, so it's just a list of numbers, and that's the x coordinate, where horizontally it's going to appear. 1 is the y coordinate, because we want them all to be the same height. This is followed by the label. Now the label is just going to be that word in our dictionary. And the width I've put as 10. And the reason I've done that is that because there are so many tiny little lines that it's quite hard to see them unless they're quite fat. So I've made them 10 times bigger than they normally would be. So it does that for every single word in our dictionary. And once it goes through the dictionary, it goes back up to the item loop and checks for the next item in our top 5. So once we've plotted all 5 of our different words, it goes on to the next part of the graph creation. Now we've put the x limit as 0 to word count, which means it goes from 0, or nothing, to the word count, how many words there are in the entire dictionary. The next thing it does is it goes through the limits. So 0 at the bottom and 1 at the top for the y limit. So basically, we're just creating a graph that is the correct size for the data that we have. The next thing we do is we put in x ticks and y ticks, but you can see we've got blank lists there. That's because we want this to be a nice pretty barcode and we don't want lots of little numbers at the bottom. So that basically just blanks out the numbers it would normally put in. We want to create a title, and I've called it Heat Map, just so that we could have a little bit of excitement. Finally, I've created a legend, and I've put it in the upper right-hand corner of our graph. The last 2 commands you'll remember are just plot show, to show the graph, and plot close, to remove it from memory so that we can make another graph if we want to. So now that we've done this bit of the programming, we can see what our barcode looks like. Now this is just a close-up so that you can see the legend, but as you can see there are little green, blue, red, and orange lines, as well as a couple purples, going across the bottom of the screen. And this represents every time each of those color-coded words appears in our text from the beginning all the way until the end. Now that we've created our barcode, it's a little bit too much information. 5 words with 5 fairly similar colors all smushed together. So let's try something a little bit more simple to read. So within a single box, I've put the entire program for creating our barcode. And that means beginning at the very beginning of our steps, which is creating the value, finding out what that top value is, all the way down to actually showing the graph and the barcode. But this time, rather than use top 5, I'm going to use just the top 1 word. So when we get to the part of our code that asks how many do we want to stop after, len top 5 is less than, we replace that 5 with just the number 1. And we have this little extra bit of code as well. If len top 5 is equal to 1, break. Now, we don't really need that, the program will work just fine without it, but it saves a few cycles. It basically stops going through the words since it's not going to add any more after one anyways. So when we bring up our new barcode by running this program, we just have the one color, the word will, written in blue, with lines going across the text. And this allows us to see not only how often it appears, but how often it appears in certain subsections of the text. Is it clustering together in certain parts? So there we go. I hope you enjoyed today's lesson, and if you did, please think about subscribing, hitting the like button, and coming back when our next is published in about a week's time.